Okay, this final example for this unit is a car traveling 100 meters per second, I should say slams inelastically, not inelasticity, into a parked car. Each car has a mass of 2,000 kilograms. What is the final velocity of both cars? So what we're trying to figure out is the velocity of them when they are together. Now remember, inelastically means when you have one car that hits the other car, they stick together and they become one object. So, before the collision occurs, I have two objects. I have the car number 1 and I have car number 2. Afterwards, they are stuck together. So, mass 1 and mass 2 are the same number. They are both 2,000 kilograms because it says each has a mass of 2,000. I know that the first car is moving at 100 meters per second, which is very, very fast. And the second car is at rest because it says it's parked. That allows me to figure out what I'm talking about here because I can say mass 1, velocity 1, plus mass 2, velocity 2, equals mass together, velocity together. So 1,000 times 100 plus 1,000 times 0 equals the total mass would be the mass of those added together, which would be 4,000. Should be 2,000 as well. Okay, so once you're here, realize that this term is 0 because 2,000 times 0 is still 0. And all I have to do is divide both sides by 4,000. So when you take 2,000 and divide by 4,000, you should realize that's half. Half of 100 is 50 meters per second. Now, a lot of times people say, oh, well, all you have to do is cut it in half. The only reason why it works in this particular case is because both of the cars have the same mass, and one of the cars was initially at rest. That's the only reason why this example works out to be half. In every other inelastic collision, you have to do this math in order for it to work. If you just try and cut it in half, it's going to be wrong.